Hey guys, all right, so we are on activity 5. We've just finished up with polynomial long division and synthetic division. We've done end behavior. We've looked at even and odd functions versus even and odd degree functions. So yeah, we've done all those things. We've taken a quiz. So just a reminder, if you need to retake that quiz, which I recommend some of you do, please make sure that you schedule that with me this week during tutorial 4B at 1:30, Monday, Tuesday, Thursday, or Friday. Let me know which day you're coming so I could have it ready to go. Otherwise, you'll have to give me a minute to add your name in the Edulastic quiz. Alrighty? Okay, so today we are going to be looking at some more polynomials. We're looking at factors of polynomials. So we are going to be factoring. You've learned to factor difference of squares. You've learned to factor perfect squares, a difference of squares. You've learned to factor easy trinomials and hard trinomials. That's what I call them. Different teachers call them different things, but you'll see what those are. You're going to learn a new method today on factoring polynomials, and that method is going to carry you through as you keep going with math. Now, if this is where you're ending with math and this is the last method you ever need to learn, and you're done. But this is the method that you're going to have to use for these, okay? So keep that in mind. We're going to determine linear factors of polynomial functions using algebraic methods. So we're going to be using some algebra today. We're going to determine the linear or quadratic factors of polynomials by factoring. We have to find the factors by factoring the sum or difference of two cubes and factoring by grouping. Factoring by grouping is the new method that you're going to learn today, and also factoring a sum or difference of two cubes. So you've done a difference of two squares. We can't factor a sum of two squares, but we can factor a difference, subtraction, of two squares. We will be able to factor a sum or difference of two cubes. So that's to the third power. So you're going to be learning that today. Okay, so that's your little brief overview of what we're doing today. Let's start with number 1. It says when you factor a polynomial, you rewrite the original as a shoot, I don't know where I was at. My dad called and I had to answer. All right, so anyways, when you factor a polynomial, you rewrite the original polynomial as a product. That means multiplication of two or more polynomial factors, okay? And we usually write them, in parentheses. Usually we have two sets of parentheses with a binomial inside. It says state the common factor of the terms in the polynomial 4x cubed plus 2x squared minus 6x, then factor the polynomial. Okay, so let's first state the common factor. Okay, well, a common factor is what all three terms have in common. We have a 4x cubed, a 2x squared, and a negative 6x. Let's look at the numbers first. The biggest number that all three have in common would have to be that 2, because 2 can go into 4 and 2 can go into negative 6. So as far as the coefficients go, the greatest common factor is a 2. Now for the x's, you have to look for the greatest x that all three have. Not the greatest one altogether, the greatest one that all three terms have. Well, the greatest x that all three of these terms have is just an x to the first power. So 2x is the common factor. Okay, it's got to be what they all have in common. Okay. All right, then we're going to factor that polynomial. Okay. So when we factor, we write the 2x, that's the common factor. We're bringing it out front of the parentheses. And when we factor something out, factoring something out means to divide it out. Oops, you guys can't see. So 4x cubed divided by 2x is a 2x. Well, since we're dividing out an x, it takes it down a degree. So now it's a 2x squared. Plus 2x squared divided by 2x. Well, 2 divided by 2 is 1, and x squared divided by x, well, take it down a degree. I just have a 1x. I could write the 1, but I don't have to. I don't need to. When we don't see a number there, we assume it to be a 1. Negative 6x divided by 2x. Well, negative 6 divided by 2 is a negative 3. And x divided by itself is 1, so it's just a minus 3. Okay? And we need to check, we're not done yet. We need to see, is that stuff inside the parentheses, this polynomial right here, this quadratic, is this factorable? we need to check. Because if it is, we're not done. If it isn't, then I can box that answer and I'm done. So I'm going to take it over to the right where there's some room under the My Notes section. And we're going to see if 2x squared plus x minus 3 is factorable. So if you had me last year for math, I always use product sum. I never use Xbox or any of those other methods because you're not going to use those methods when we get to stuff like this. So product sum is the method that works on them all. So I always stick with this method, okay? But as you're learning, if you need to check your work with the Xbox method or whatever, you totally can. That's not a problem. Okay, so the product is whatever A times C is. Remember we did an IXL on this? So here are my ABCs. A is 2, B is the 1 right there, and C is -3. So 2 times -3 is a -6. It's got to add up to a 1, a sum of 1, okay, because your sum is always your B. All right, two numbers that multiply to -6 and add up to 1, well, they've got to be 3 times 2, but the negative needs to be on the 2, because 3 plus a -2, or in other words, 3 minus 2 is 1. So these are the droids I'm looking for. And because this is a hard trinomial, hard meaning the leading coefficient, the A value is bigger than 1. And it's a 2. So this is definitely a hard trinomial. This is where we have to take the middle term and replace it with its new numbers. So we will have 2x squared. Let's do plus 3x. Then minus 2x, and then minus 3. So 1x is equivalent to 3x minus 2x, because those are the numbers that work to combine to get a 1, to get that 1x, okay? And then we break it in half and factor each side. Try not to cover up the sign that when you break it in half, because you're going to need that sign. We're going to need to bring it down. So on the left, we're going to factor each side, 2x squared plus 3x. Well, the only common factor between just those two terms is an x, and we're going to divide it out. 2x squared divided by x is a 2x. 3x divided by x is just a 3. That minus sign I was talking about, we got to bring down. So that means whatever we factor out, it's got to be negative. Well, 2x and 3 have nothing in common. So the one thing that we are allowed to factor out when they have nothing in common is a 1. But it's got to be a -1 because we had to bring down that sign. So all that means is when we divide, we're going to get a sign change. -2x divided by -1 is positive 2x. -3 divided by -1 is positive 3. And guess what? When the stuff in the parentheses is exactly the same, that means, first of all, it is factorable. Second of all, you're doing it right. So 2x plus 3 is one of the factors. The other factor is the leftovers. Just slap them together. Just like you would pulling leftovers out of the fridge. Just slap it together and make a meal. So x minus 1. So it does factor down to 2x plus 3 times x minus 1. So we're going to return back to the problem over here. And now we can put in there, oops, focus, camera focus. So now we can say this equals, there was a factor of 2x out front, and the stuff in parentheses became two binomial factors. So 2x plus 3 in parentheses, and x minus 1 in parentheses. And now I'm going to box that answer. So this polynomial, 4x cubed plus 2x squared minus 6x, has 3 factors. One of the factors is 2x, another factor is 2x plus 3, and another factor is x minus 3. Alrighty, so number 2, it says to consider the expression x squared times x minus 3 plus 2x times x minus 3 plus 3 times x minus 3. And the first question is, how many terms does it have? Well, look what you have in between each plus sign. We have a term right here, plus sign. We have a term right here, then a plus sign. And then we have a term right here. So there are 3 terms. What factor do all 3 terms have in common? Well, let me get a highlighter for this one. Make it green. Don't you see that they each have an x minus 3? Remember, if it's in parentheses, it's a factor. just like as if it's by itself out front. So x minus 3 is the factor that all three terms have in common. So now it says, okay, well, if that's the common factor, then factor it out. So if we divide out an x minus 3, we'll bring it out front, and we have to put it in parentheses because it's a group of two terms. If it was just one term, then I wouldn't need the parentheses. All right, so if I factor that out, x squared times x minus 3 divided by x minus 3, well, the x minus 3's will cancel, and all I will have left is an x squared. 2x times x minus 3 divided by x minus 3, well, the x minus 3's will cancel, and all I will have left is a positive 2x. Minus 3 times x minus 3 divided by x minus 3, the x minus 3's will cancel again, and all I will have left is the minus 3. So that is factored, and we always need to check to see if this is factorable. Is it factorable? Let's check. So let's take it to the right. So x squared plus 2x minus 3, product sum. So A is a 1 this time, B is a 2, C is a negative 3. So A times C is negative 3, because that's 1 times negative 3, and it's got to add up to a 2. So the only way that we could do this is 3 times 1, and one of these has to be negative. Negative 3 plus 1 is negative 2. All right, so that doesn't work. So what about 3 times negative 1? Well, 3 minus 1 equals positive 2. Oh, those are the droids I'm looking for. Okay, so since those are the numbers, I could do what I did up here, and you could do all these steps, break it in half, factor each side, but I don't have to because the leading coefficient is a 1. It's an easy trinomial. So all I have to do is put an x and a positive 3 and an x and a negative 1. And it was factorable. So yes, it is factorable. So my final answer then would be I have a factor of x minus 3, and then x squared plus 2x minus 3 factored down to x plus 3 times x minus 1. So x plus 3, x minus 1. And that's my final answer. See, when it says to factor, you aren't done until you're done, pretty much. There's really no other way to say that. It's how low can you go? Just like when you're reducing fractions. How low can you go? Here's example A. You could take a look at that, but we're going to go on to the next page. We're going to do try these A. It says use example A as a guide to factor. Well, we've already had a couple examples, so we don't really need to use example A as a guide, but it's there for you in case you need it. So let's take a look at what we have here. We have 6x squared plus 19x plus 10. So let's write that down. 6x squared plus 19x plus 10. And I want to factor this, so we got to use product sum. And let's identify the ABCs. A, B, C. Because we know the product is always A times C, and the sum is whatever B is. But you guys had lots of practice with that on the IXL, so you should be good. If you didn't do that IXL, you might need to go back and do it so that you get that extra practice. Or if you did it, but you're still kind of like, I'm not sure, then you should go back there and do some extra practice. All right, so let's see. A times C, 6 times 10 would be 60, and it's got to add up to 19. Okay, two numbers that multiply to 60 and add up to 19. Well, I know that 60 is obviously 6 times 10, but 6 plus 10 adds up to 16. That's not it. Nope. Okay. Let's see. If I divided 60 by 2, it would be 2 times 30, but that's going to be 2 plus 30. That's going to be 32. That's not going to work. What ends up working is 4 times 15, because 4 times 15 is 60, and 4 plus 15 equals 19. So these are the droids I'm looking for. Okay, so now that I know what my numbers are, let's remember this is a hard trinomial because the leading coefficient is a 6. So we have to do the replacement. Okay, so I have 6x squared plus, instead of 19x, equivalent to that would be 4x plus 15x. And it doesn't matter the order that you put these numbers in, because you might have thought to put 15 plus 4 instead. It'll work just the same. Okay, and then we gotta break it in half and factor each side. On the left of the break, 6x squared plus 4x. Let's see, they have a common factor of, let's see, a 2 can go into both. That's the biggest number that can go into both 6 and 4. And the biggest x that they both have is an x. So let's divide it out. 6x squared divided by 2x is 3x. 4x divided by 2x is a positive 2. Okay, bring down the plus sign. Now remember, for this to be factorable, in the parentheses on this side, we're going to need to get a 3x plus 2. So let's see what 15x and 10 have in common. They have a 5 in common, and that's it. So 15x divided by 5 is 3x. 10 divided by 5 is 2, and there we go. Woohoo! So they're both the same. We're doing it right. And 3x plus 2 is one of the factors. The other factor are my leftovers. Slap them together. You get 2x plus 5. And always box your answers. Makes it easy for me to see. Okay. All right. Factor each trinomial. So we have a couple more, so let's go ahead and do these. All right. So 3x squared minus 8x minus 3. If we do product sum. Let's zoom in a little bit because I'm writing kind of small. All right. The product, well, let's identify ABCs. Okay. A times C would be 3 times negative 3. It's negative 9. And B is negative 8. So two numbers that multiply to negative 9 and add up to negative 8 are going to have to be negative 9 and a positive 1. Because 3 times 3 won't do it. That'll cancel each other out. It's got to be negative 9 and negative 1. Or, sorry, negative 9 and positive 1 because that adds up to negative 8. These are the droids I'm looking for. So we're going to replace the negative 8x with the new numbers. Okay. And we will get 3x squared. And instead of negative 8x, we'll replace it with negative 9x plus a 1x minus 3. And then we'll break it in half and factor each side. On the left of the break, 3x squared minus 9x, the greatest common factor is a 3x. And when I divide it out, 3x squared divided by 3x is 1x. Negative 9x divided by 3x is a negative 3. Bring down the plus sign that's there after the break. And x minus 3 has nothing in common, so we have to pull out something, though. And the one thing we can pull out when there's nothing in common is a 1. You have to write that. So these are the same, so that means we're doing it right. And so x minus 3 is one of the factors. The other one is the leftovers, 3x plus 1. Slap them together. And there is our answer. Easy peasy lemon squeezy, just a little bit of work to add to it, but it's what we were reviewing at the beginning before we even started into the book. So this is still review. None of this is new yet. 2x squared plus 7x plus 6. All right, let's try it. Product sum. It's a hard trinomial because the leading coefficient is a 2. It's bigger than 1. They're my ABCs. It helps when you label the ABCs. If you don't need to, you don't have to, but it is nice when you know them, you know. A times C is 12. B is 7. Let's see, I have 6 times 2 or 4 times 3. It's got to be 4 times 3 because 4 plus 3 is 7. These are the droids I'm looking for. Okay, so we're going to replace the middle term with the new numbers. So let's see, we'll have 2x squared. And then instead of 7x, we'll have a plus 4x plus 3x, and then the constant plus 6. All right, break it in half, factor each side. On the left, we could factor out a 2x, and we'll have x plus 2. 4x divided by 2x is 2. Bring down the plus sign. On the right, we could factor out a 3, and we'll have x plus 2. Woohoo! So these are the same, so that means we're doing it right. X plus 2 is one of the factors. And my leftovers are 2x and a plus 3. Slap them together. 2x plus 3, and there is our answer. The factors x plus 2 times 2x plus 3. See, it's not so bad. All right, example B shows the new method, and it has to do with factoring by grouping. So this is going to be new for you guys, sort of. It's sort of new for you guys, okay? The reason why it's sort of new is because we've actually been factoring by grouping when we've been doing product sum on the hard trinomials. Anytime we have 4 terms and we break it in half and factor each side, we are factoring by grouping them. And groups have to always be in even numbers. So the book describes it differently. So I don't like the way the book describes this example. So I'm going to do example A and B separately. So I'll put them up here, and I probably will use a darker pen because that blue pen won't look good over here. So this is example B. I'll actually do one of these. So I'll just do the first one. So it is 3x cubed plus 9x squared plus 4x plus 12. And we're going to factor that by grouping. So factoring by grouping means you have to have an even number of terms. You have to have 4 terms. 4 is an even number. And this is what we do. You break it in half and factor each side. So the common factor between 3x cubed and 9x squared is a 3x squared. When we divide that out, we have an x plus 3 left. Bring down the plus sign. On the right of the break, we have 4x plus 12. The greatest common factor is a 4. And when we divide it out, we'll have an x plus 3. These are the same, so we're doing it right. So x plus 3 is one of the factors. The other one are the leftovers, 3x squared plus 4. And I can't factor that any further, so that is my answer. So I want you to notice something about this example. Notice that it didn't start with an x squared. It started with an x cubed term as the leading term. And so that's a higher degree polynomial. So we can factor those higher degree polynomials only if we can break it in half and factor each side. That's the only way that it'll work. Okay, otherwise there will be other methods that we can do that. So this was letter A. Okay, so let's go ahead and go down to the try these B, and let's do it. Okay, so I've got 1, 2, 3, 4 terms. Break it in half, and we're going to factor each side. On the left, 2x cubed plus 10x squared, it has a 2x squared in common. And let's divide it out. 2x cubed divided by 2x squared leaves me with just an x, plus 10x squared divided by 2x squared is a 5. The x squareds cancel. Oh, there's a minus sign after the break, so that means we're going to factor out a negative number. Negative 3x and negative 15 have a negative 3 in common. Negative 3x divided by negative 3 is x. Negative 15 divided by negative 3 is a positive 5. And hey, check that out. They both have the same factors inside, so we're doing it right. It's factorable, and one of the factors is x plus 5. The other one are the leftovers. Slap them together. 2x squared minus 3. Now, anytime you get an x squared, you always want to look at it and be like, can I factor that anymore? Nah, the only way that we could, this is only 2 terms, it would be if it were a difference of 2 perfect squares, and 2 is not a perfect square, and 3 is not a perfect square. So we're done. We done. Let's look at letter B. 4 terms. This time the highest degree is the 4th degree, but that doesn't mean we can't do it. We still can factor by grouping. On the left, 4x to the 4th plus 7x cubed. The only factor they have in common is an x cubed. Divided out, 4x to the 4th divided by x cubed is a 4x. 7x cubed divided by x cubed is just a 7. Bring down the plus. 4x plus 7 has nothing in common, so the one thing we can factor out is a 1. And nothing changed because it's a positive 1 that we divide out. These are the same, so that means we're doing it right. And 4x plus 7 is one of the factors. And the leftovers, slap them together, x cubed plus 1. what's funny about this one is that later on in these notes, you will be able to factor that. This is a sum of two perfect cubes, because x cubed is a perfect cube because it's cubed, hello. And 1 is a perfect cube because 1 to the third power is still 1. How about that? So it's coming up. All right, next page. So, do I want to do any of these? Oh, we've done a lot of those. Okay, let's go on to the difference of two squares. So that's review for you. That is not new at all. Difference of two squares. They can be factored using a specific pattern. So whenever you have a squared minus b squared, it factors down to a plus b, a minus b. So you've done that a billion times. A difference of two cubes and a sum of two cubes also have a factoring pattern. It's similar, but their patterns, it's a cube, so it's a little bit different, okay? But they're similar. All right, so we have a difference of cubes and we have a sum of cubes. So I'm going to do difference of cubes in yellow, mellow yellow, and I'll do sum of cubes in blue. Make it blue. Every time I say something like that, it makes me think of, what Disney movie is that? Sleeping Beauty. It used to be my favorite when I was growing up. My favorite color is pink. All right, what patterns do you notice in the formulas that appear above? Okay, well, let's look at the, excuse me, difference of cubes. We have a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. And then in the sum of cubes, we have a cubed plus, for sum, b cubed equals a plus b times a squared minus ab plus b squared. So I'm noticing, and I would have you guys answer me in class, but I don't have that option right now, obviously. So hopefully you're thinking to yourselves what patterns that you see, but they all have the same combination of letters. The only difference is there's different signs. Like here we have a minus sign, there's a plus sign. Here we have a plus, there's a minus. Here's a plus, there's a plus. That was the only part that's the same. Okay, so what we can say is it uses all the same combo of letters with different signs. So for the difference of cubes, it goes minus plus plus. For the sum of cubes, it goes plus minus plus. Okay, so if we can remember these, coming up with a combination of letters is easy to remember. Remembering the signs is what's hard. Okay. All right, so it says in number 9, factor each difference or sum of cubes. So there's not a whole lot of room to work in this area. So I'm going to take it to the My Notes section. So we'll start with 9A. So number 9, letter A is x cubed minus 8. So obviously because of that minus sign, we're looking at a difference. And it is a difference of cubes, of two cubes, because x cubed is cubed, so it's automatically a cube. 8 is cubed because it's the same as 2 to the third power. So this is how I like to write it. So I know that this is x to the third power, that's what's making it cubed, and 8 is 2 to the third power. 2 times 2 times 2 is 8. So technically, this is my A, and this is my B for our little difference of cubes formula. Okay, so we're going to follow that formula to the T. And that formula is, let me write it down in a different color. It is a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Okay, so I'm following this to the letter, literally. All right, so I can say x cubed minus 8 equals. Well, my a is the x there, and b is the 2. So a minus b is going to be x minus 2. A squared is the first term in the next parentheses. So a is x, so x squared would just be x squared. Plus ab means a times b, so a is x, b is 2, x times 2 is a 2x. And then plus b squared. Well, b is a 2, and 2 to the second power is 4. Okay. And just so you know, anytime you use a sum or difference of cubes, this trinomial is never going to be factorable. So you don't even need to bother checking. It will never be factorable. I used to know why it doesn't factor, but I don't. That was the upper level math eons ago, because I'm old. All right, letter B is x cubed plus 27. So obviously, because of that plus sign, this one is a sum, because sum means to add in math. And obviously, x is cubed, so it's perfect cube. And 27 is 3 to the third power. 3 times 3 times 3 is 27. So 27 is a perfect cube because of that reason. Okay, so this is my A and this is my B. And I'm going to use the sum of cubes formula. So the sum of cubes formula, I'll just write it real quick, is a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. Okay, so let's plug it in. So we have x cubed plus 27 equals. All right, my a and b is x and 3. So x plus 3 times a squared, so x squared, minus a times b, so x times 3 is 3x, and then b squared plus b squared, so 3 squared would be 9, so plus 9. And there we go. Literally just following that formula to the T. All right, let's try letter C. Letter C is 8x cubed minus 64. Okay, well, obviously because of the minus sign, this is a difference. I'm just going to put diff. Okay, so it's a difference of two cubes. And we know that 8 is 2 to the third, and x is x to the third, obviously. So 2x to the third. And then 64 is 4 to the third. Okay. All right. So this is my A, and this is my B. So let's go ahead and write it out. So we'll have, I'll just put equals, and the difference of cubes formula is up here, and it's also to the left. So my A is 2x, my B is 4, so A minus B will be 2x minus 4 times A squared, so 2x quantity squared, so 2 squared is 4, and x squared is x squared. And then it goes plus, because it goes minus plus plus, A times B, so 2x times 4 is an 8x, and then B squared, so 4 squared is 16. All right. And there we go. Pausing for a second just because I was looking at my notes and the way I did C was wrong. I messed up when I factored, but I did not mess up here. That's what's nice. Okay, letter D. 27 plus 125x cubed. All right, this throws me through a loop when it's not in standard form. So I like to switch it around and write it like it's supposed to be written. The 125x cubed and then the plus 27, okay? This is not standard form. The second way I wrote it is standard form. So anytime that happens and they try to throw a curveball at you, rewrite it. You can totally do that. There's nothing wrong with that. Okay, so what's being cubed here? 5 to the third is 125, and obviously x to the third is x to the third. So 5x to the third, and we already know that 27 is 3 to the third power. So here's my A and here's my B. So this is going to equal, this is a sum, obviously, because it's a plus sign in between, sum of cubes, so we're going to use the plus minus plus formula. So first of all, A minus B, so 5x minus 3. Okay, or sorry, plus, so it's, shoot, plus minus plus. Well, at least it was easy to change it. So 5x plus 3, my bad, because I'm looking at the sum of cubes formula right here. Then a squared would be 5x quantity squared. So 5 squared is 25, and obviously x squared is x squared. And then minus a times b. 5x times 3 is 15x. And then plus b squared. Well, 3 squared is 9. Boom shakalaka. Right, and that was letter D. Okay. Let's look at above 10. It says some higher degree polynomials can be factored using the same patterns or formulas that you've used when factoring quadratic binomials or trinomials. So it says to use the difference of squares formula, a squared minus b squared equals a plus b times a minus b, to factor 16x to the fourth minus 25. It may help to write each term as a square. Okay, so we're going to break this down. This is obviously a difference of two perfect squares, but we're going to break it down the way that we broke it down for the cubes. You know how I showed what was being cubed? Well, this is a difference of squares, so let's show what's being squared. So let's see. 4 squared is 16, and x to the fourth would be x squared. 4 squared, 16, x squared squared, 2 times 2 when you multiply the exponents is a 4. And then the 25, obviously, is 5 squared. So this is your A and this is your B. So remember, this is a difference of squares. So we use that formula that you guys have known from Math 2. So when we factor this, it'll be A plus B, A minus B. So 4x squared plus 5 and 4x squared minus 5. And then on the minus one, we can only factor difference of two perfect squares. This first term is a perfect square, but 5 is not. So I can't factor it anymore. That's the answer. Okay. So sometimes it might throw a curveball at you. You're going to see that. And you need to decide, okay, is it a perfect square or is it a perfect cube? So what formula am I going to be using? Pretty much that's what you got to ask yourself. All right, so let's turn the page. And let's take a look at this table, number 11. It says explain the steps used to factor 2x to the fifth plus 6x squared minus 8x. Okay, so looks like they pulled out a 2x in front and factored that out. So what did they do? They factored out a greatest common factor. So I'll put GCF for greatest common factor. Okay, then on the next line, they still have the 2x, but now they have two binomial factors. Oh, okay. So what they did was they took this and they factored it. So that's 3 terms, so that's a trinomial. So they factored the trinomial. Okay, all right, and then on the last step, now they have 1, 2, 3, 4 factors. They went from 3 to 4, so they added an extra factor. Where did that come from? Well, they both still have the 2x. They both still have the x squared plus 4. The x squared minus 1 looks like it turned into this. Well, that's because x squared minus 1 is a difference of two perfect squares, and we know that that'll factor down to x plus 1, x minus 1. So they factored the difference, I'll just put diff, of squares. I'll put SQ for squares. All right. So number 12, it says to use the formulas for quadratic binomials and trinomials to factor each expression. So there's not a lot of room to work here, but I think I can do A right there. A is short. Well, this is a trinomial, right? So we could product sum it out. The product is A is 1, B or C is negative 20, so negative 20. And it's got to add up to 1. Okay. Well, 5 times 4 is 20, so it's got to add up to a positive 1, so the negative needs to be on the 4, because 5 minus 4 is 1. So because the leading coefficient is a 1, this is an easy trinomial. But instead of x plus a number, because x times x is x squared, I have an x to the 4th. So the only way to get an x to the 4th is to have an x squared times an x squared. And then you put in the numbers. So a positive 5 and a minus 4. Here's the kicker. We're not done yet, because I notice, and you should notice too, that x squared minus 4 is a difference of two perfect squares. So this can continue factoring. So we'll still have the factor of x squared plus 5, because that doesn't just magically disappear. And then x squared minus 4 factors down to x plus 2x minus 2. And now I cannot factor that anymore, and I'm done. So that one factored down to 3 factors. All right, we'll take b over to the left, because I don't think I'll have enough room for that one. Oh, maybe I will. Hold on, never mind, maybe I will. It's a difference of two perfect squares. I see the minus sign. And it's not a cube because it's to the 4th power, so it's got to be a difference of two perfect squares. So let's see. I'll write it down here. What is squared? Well, to get a 16, it must be 4. And then to get x to the 4th, it must be x squared. So 4x squared is being squared. And then 81 is obviously 9 squared. Okay, so when that factors, we'll get 4x squared plus 9, because it's a difference of squares, and 4x squared minus 9. Okay, can I still factor this? Well, yes I can, because of the 4x squared minus 9. This is another difference of two perfect squares. Okay, so the 4x squared plus 9, like I said in the last problem, it's still a factor, so it's not going to magically disappear. You don't do magic when you do math. And although it might feel like it sometimes. Let's see, 4x squared minus 9, let's see, that would be a 2x. So 2x plus the square root of 9 is 3. 2x minus 3. And now I cannot go any further. There's nothing left to factor, so I am done. You're done when you can't factor anymore. All right, and then the x minus 2 to the 4th plus 10 times x minus 2 squared plus 9. Okay, so this is a trinomial. There's 1, 2, 3 terms. The leading coefficient is a 1, b is 10, c is 9. So if I do product sum, I'll have, let's see, 1 times 9 is 9, and it's got to add up to 10. So it's got to be 9 times 1, because 9 plus 1 equals 10. So those are the droids I'm looking for. Okay, so it's an easy trinomial though, so my binomials will look like this. I'm going to make them kind of big. All right, so this is to the 4th power. So remember, I need it to be something squared times something squared to make this happen. Well, that something is the x minus 2 squared. X minus 2 squared. Okay? And then, let's see, I need my numbers. A plus 9 and a plus 1. And these are sums of two perfect squares, and we can't factor those, so guess what? As crazy as that looks, that's the answer. So sometimes they'll get a little crazy like that, but usually not. Okay, they won't usually throw those at you. All right, your homework is not going to be from the book today. It's going to be the additional practice. I forget what numbers they are, but you'll see that under the assignment in Google Classroom. Have a good one, you guys.